Metal Recycling and Electromagnets by Krishna and Anastasia. Metals are everywhere. They're used in cans, machinery, cutlery, foil, electric cables, or even packaging materials. They are very commonly used because they have suitable properties, such as good conductors of heat and electricity, malleable, and strong. But why should we recycle these everyday materials? Certain metals can be extracted from their ores. For example, iron is extracted from hematite, and copper is extracted from malachite. These metals are extracted from fossil fuels, so they have a limited supply on Earth. They are finite. Also, these fossil fuels contain sulfur, causing acid rain, which has a negative effect on the environment. Overall, the process is bad for the environment, extremely time-consuming, and expensive. So by recycling, we save energy and metals, since we don't have to dig up more. We also protect the environment because when mining for ores, it destroys animal habitats and creates visual and noise pollution. Less mining leads to less acid rain, pollution, and habitat destruction. Thirdly, recycling is good for the economy, as when less energy is needed to extract metals, less money is used. So what metals can be recycled? A widely recycled metal is aluminium. Today, 50% of aluminium materials are made of recycled aluminium. Steel can be recycled. Most steel mills today primarily use scrap steel instead of pig iron from blast furnaces. Copper is also recycled. This is a more energy-efficient process than the extraction from its ore. And since the copper ore supply on Earth is being depleted at a very fast rate, recycling and other environmentally friendly methods are the only good choices. There is also cast iron, bronze, and tin. Silver and gold from jewelry are also recycled. However, these metals are found as native metals. As a result, the issue isn't the energy cost, but the rarity of these metals. Which is why the main source of gold has become recycled electronic goods, like computers, which have their electrical contacts plated in gold. Gold is used there in order to prevent corrosion in computers, as well as enhancing electrical connection.
There are two types of metals, ferrous and non-ferrous. Ferrous metals are attracted to magnets while non-ferrous metals aren't. Ferrous metals have high carbon content, which makes them vulnerable to rust when exposed to moisture. However, there are two exceptions. Wrought iron resists rust as it is very pure, and stainless steel is protected from rust as it contains chromium. The main advantage that non-ferrous metals have is their malleability. Non-ferrous metals also have no iron content, giving them a higher resistance to rust and corrosion, and making them ideal for gutters, liquid pipes, roofing, and outdoor signs. Lastly, they are non-magnetic, which is important for many electronic and wiring applications. But how do we recycle these metals? First, let's see how metals are transported to where they need to be in order to be recycled. Electromagnets in metal recycling are used to move large sums of scrap from one place to another. In a scrapyard, a crane has a large iron disc attached that is not a permanent magnet but can be turned on and off. Firstly, the crane would lower the electromagnet to the pile of scrap metal, then turn on the electricity which activates the magnet. The scrap is then attracted to the electromagnet, and the crane can move it to another area. Once at the desired area, the crane then turns off the electricity so that the scrap metal falls into the correct place. Electromagnets. All electromagnets work following the same principle. An electric current in a wire creates a magnetic field. The connection between electric currents and magnetic fields was first noticed in 1820 by a Danish scientist named Hans Christian Ørsted through an experiment with a compass and an electric current. In the experiment, it was seen that the needle followed the electric current when it passed through a wire, thus demonstrating a magnetic field.
Later on, a French scientist, André-Marie Ampère, developed a theory where he believed that all magnets create a magnetic field through electric currents. His theory was reasoned by the thought that the magnetic effect created in steel or iron was because of the electrons circling, which create an electric current causing a magnetic field, which proved to be correct. Nowadays, electromagnets are used all the time in our daily lives.
What are the advantages of an electromagnet? Some advantages include being able to turn it on and off, allowing cranes with electromagnets to move large objects made with magnetic materials. In addition, the magnetic strength can be increased. Electromagnets are also not restricted to one type of metal. Iron, nickel, and cobalt can be turned into electromagnets. So what do we do after metals have been transported by electromagnets? Firstly, crane operators in scrapyards place materials, objects, or products with metals that are shreddable and places them onto a conveyor belt. A conveyor belt is a continuous band of rubber, fabric, or metal that is used to transport objects from one place to another. From there, it is shredded into pieces, and an industrial vacuum sucks up any rubber or glass mixed in with the shredded metal. The ferrous metals then stick to a magnetic drum, while everything else drops onto a conveyor belt below. Pickers then remove any unwanted materials in the metal scraps, and the ferrous metals are ready for shipping. However, non-ferrous metals are still mixed in with the shredded debris, so these are taken through an extended process. The shredded debris is taken to a machine called a trommel, which is a rotating drum that separates them by size. Any leftover residue is just trash. Afterwards, the material from the trommel is evenly dispersed onto a conveyor belt, which leads to a machine called the eddy current separator. Inside, a powerful rotating magnetic drum repels any non-ferrous metals, which makes them go onto a storage bin. The process in the separator is repeated in case there were any non-ferrous metals missed. The worthless residue is taken to a trash heap, while the non-ferrous metals are taken to a bin for sale. These metals are taken to another plant where they will be sorted into different metals.
Let's make our own electromagnet and closely look at how it works. First, we wrapped a copper wire around a nail. Copper wire is used as it is an insulator of electricity. Then, we put a battery in between the copper wire. The battery will power the electrons, making the electromagnet magnetic. This is demonstrated when picking up a paperclip, a metal.
We now know the benefits of metal recycling as well as how it works. But are there any negatives? The main issue in recycling metals is the separation process in the waste containers. This is because many metal products are alloys. An alloy is a mixture of two or more elements with at least one of the elements being a metal. Many metal products are made into alloys to increase strength and other desirable properties, but not all alloys can be recycled, such as manganese-aluminum alloys. Some alloys which can be recycled need to be molten and separated into the constituent metals, hence making it a more energy-costly process. Also, before recycling, metal products have to be collected, then transported to recycling facilities. Transporting all these metals need fuel usage, therefore increasing carbon dioxide emissions, contributing to global warming and pollution. But overall, recycled metals and the recycling process usually uses significantly less energy than the extraction from their ores, making recycling metals a better choice. Thank you for watching, and we hope you enjoyed this video on recycling metals and electromagnets by Krishna and Anastasia.